Welcome, and this week we're talking about link aggregation. This is not near as intense as last week's spanning tree. Instead of 3 little mini sessions on learning about spanning tree today, we are going to just do 10 quick slides to get you going on the basics of ether channel. So let's take a look at this. Now, on our first update here, we're going to go through and talk about link aggregation, and we use 2 types of link aggregation here. In link aggregation, what we're doing is we're taking physical ports, we're taking a few different physical ports and bundling them together to increase the bandwidth and processing. This can be used as uplinks between switches or between a switch and a server. But what we're bundling are the physical interfaces, say taking 4 100 gigabyte interfaces and bundling them into one 400 gigabyte channel. And that way we can expand the data, and they can share the buffer, and the throughput can be much greater. All right, so by aggregating links between devices, we can greatly increase the efficiency of the switch. So this is the symbol you'll see when there's a loop around them. You know that ports have been bundled into a channel. So in this picture here, if we note the zoom, this little loop here, this tells us that it is a port channel and not a spanning tree link. So what happens is STP would not be in effect here. Okay, just a little trick. Now, advantages of ether channel are several. These are the quick bullets. It's easier to configure because you configure one ether channel interface that manages all of the physical ports for you, so you only have to do one configuration to capture all the ports. And it relies on the current ports, and it load balances, and it's one logical link by spanning tree. So spanning tree will take a look at the ether channel and consider it one interface, and you don't have to worry about blocking or the redundancy. Okay. Now, if you have 2 ether channels, spanning tree will still work in that situation. Now, there are some technical restrictions to ether channel. Notice here that port channel, here, let me zoom in for it, we'll take a look. Notice here, logical port channels, we have 1 through 6 and then 9 through 12. And they are one channel group. They're bound into a port channel. All right. Now, in the old days, you had to be careful that they were adjacent ports, but that was on a previous design backboard. I think now, like you see, the gigabit modules are gathered together, and the 10-100 ports, 1000 ports are all bundled together as well. They have to be like-minded on either side. So, and they can go up to 8 times, all right? So we have ether channel full duplex up to 800 megabits for fast ether channel, or 8 gigabits if they're gigabits each. So we can bundle up to 8. We can, ether channel can get up to 16 configured Ethernet ports on both sides. All right. So 6 ether channels can be put onto a switch as well. And the way that this is handled is using the port aggregation protocol. This is a Cisco proprietary one. We'll also learn about the open source one in just a moment. And there's just a couple of quirks that, if we think about them, it's not going to be a big deal. So the port aggregation protocol has different modes, and this, the manual configuration is on. If you turn it on both of them, then a port channel or an ether channel will be created. But it can also auto-negotiate to save time in configuration mode. But both sides, remember, this has to be done on both ends of the link, on both switches. So one has to be turned on to auto negotiate and desirable, and the other has to be just desirable so that they will come up in link. All right. But there's also a desirable desirable means it will take a setup if it's asked by another, but it's not initiating a discussion like auto does. So, and pardon me, auto is just passively waiting for the other side of, well, pardon me, and desirable is actively asking if the other side can participate. So one side has to be at least desirable for it to be turned on automatically. All right? And the other one has to be configured as auto, meaning it will take what it gets. So here we have the breakdowns. If they're both on, they'll work. If one is auto desirable and the other is desirable, then they'll both talk about it. If one is desirable and the other one's not configured at all, well, it has to be turned on for anything to happen. And then the same is true here. If one side is on and the other is desirable, it won't work because the desirable side will be asking the on side, hey, do you want to do it? And the on side's like, no, I'm not participating in any negotiation. I don't have any protocols coming and going. That's what on means, is no port aggregation protocols are being exchanged. It's a manual setup. A little bit confusing, but if you think about it and look at the chart, it does make sense. Okay. So, configuration guidelines. Well, we have to have matching sides. Things you have to have like ports. You can't go from 100 megabit to a gigabit. They have to be physically the same type of ports. Both switches have to have ether channel. And the duplex has to be the same, and they also have to be in the same VLAN. So if some of your interfaces are in one VLAN and one's in another, it won't conform into one because, remember, you're taking 4 ports and making them one. So it can only go into one VLAN. You only get one VLAN per channel. And the configuration, we'll be doing this in the lab. But the first thing you have to do is turn it on. It's off by default, so you choose a range of interfaces that you're going to work with. Here, sorry. We're going to choose a range of interfaces, and then we say channel group, and then we give it a name. 1 happens to be the name here. So channel group, and then we turn it and make it active because it's off by default. And then at that point, we're configuring a port channel interface, which is all 4 at once. We're not doing an individual interface, so we have to call it by name. So now we go into interface port channel 1, because that's what we named it, and we make it all a trunk, and then we allow a few VLANs on that trunk. And that's the basics of configuration. And then we have some show commands showing the port channel, showing the summary. If you have more than one port channel configured, that will show all of them. And it'll also say which interfaces are going. Now, I told you this was going to be quick, and we are there. So let's take these slides to the lab, and we'll get going. So, thanks again, and we will see you in the lab. Bye-bye.